Imagine you're programming a swarm of um, decentralized self-repairing robotic miners
Mm.
for a deep space deployment.
Right.
And your primary testing environment isn't a NASA supercomputer. It's a heavily modified Minecraft client.
Which sounds completely insane.
It sounds like a joke, right?
Mm-hmm.
But today, we are tearing into the Colony Engine design document. It's the expanded version. And if you spend your days knee-deep in simulation parameters or voxel-based pathfinding, or even like the biological realities of ant behavior, you already know the trap of the God view.
Oh, yeah, for God view.
Right. We're talking about the pervasive assumption in simulation design that AI entities just possess this free omniscience. I mean, if a scout in a standard real-time strategy game sees a flank opening, the central CPU, the hive mind, instantly registers that spatial data.
Yeah, instantly. Zero ping. And we see that free omniscience everywhere in voxel modding as well. Take the standard settlement architectures, like the jigsaw blueprint systems in mine colonies.
Oh, sure.
If one agent hits a deficit in Oakwood, the central town hall immediately updates its global state.
Right. Everyone just suddenly knows.
Exactly. The information propagates at zero cost and zero latency. But the author of the Colony Engine document frames this as a fundamental failure. Well, a failure if your goal is either accurate zoological modeling or robust robotic testing.
Okay.
Because the engine's core paradigm is finite information propagation.
Finite information propagation. So real ants don't have Wi-Fi.
They absolutely do not.
You physically have to move the data. The simulation basically cripples the AI on purpose. But looking at the architecture outlined here, this isn't just about slowing things down for realism, is it?
No, not at all.
By forcing the simulation to rely on physical carriers for information, the engine places stigmergy at the absolute center of its operating logic. And we usually talk about stigmergy as a biological quirk, coordinating through environmental modification rather than direct communication.
Right, like leaving a scent trail.
Yeah, exactly. Yeah. But this document treats it as a foundational computational layer. Okay, so let's unpack this a little. In most games, playing a faction is like playing chess where all your pieces share a single brain.
Mm-hmm.
But this document suggests giving each piece its own tiny, fallible brain. Doesn't making the AI dumb actually make programming the game infinitely harder?
Oh, it makes it incredibly difficult. It's a massive headache. But it creates a space where communication topology itself becomes a strategic resource. And that constraint forces a cascading series of design architectures.
Okay, walk me through that.
So if the colony's central belief state can only be updated by entities returning to a specific coordinate, like writing to a local blackboard at the nest,
Right.
then you have to manage that physical network. In standard models, an agent acting on a 5-minute-old data point is a bug in the state machine.
Right, it's a glitch.
Yeah, it's broken. But here, stale orders are the intended mathematical baseline. You are perfectly simulating relay latency. The lag isn't network packet loss. It is the physical distance the messenger has to walk.
The actual blocks they have to traverse. Wow. So since the queen doesn't magically know a scout is under attack, the simulation requires these physical, fallible information carriers. And the document breaks this down into 3 specific signaling channels, right?
Yes, 3 distinct channels with completely different biological and economic trade-offs. The first one is the address channel, the couriers.
Right, the couriers.
We are looking at a highly targeted, content-rich vector here. A courier ant carries an explicit payload. So maybe it's a matrix of map coordinates or an identity roster for a task group.
Like a dedicated hard drive on legs.
Basically, yeah.
Okay.
But because that data is physically bound to the carrier, the latency is incredibly high, and the vulnerability is huge.
Because if they die...
If you send a courier out, you are committing a worker to a round trip that consumes baseline caloric burn. And if that unit is intercepted, the data packet doesn't just drop.
It's permanently deleted.
It's gone forever from the simulation. The colony era's central model just remains entirely desynchronized from the actual field state.
Which is a massive economic risk for the colony.
Huge risk. Which is exactly why the engine heavily weights the second channel, the broadcast channel.
The pheromone trails.
Right. This is where the mathematical interaction of stigmergy actually solves the engine's processing overhead. Pheromones are anonymous, they decay, and they self-optimize based on successful round trips.
Okay, so how does that work in the voxel space?
Well, when a scout finds a caloric source, it lays a primary gradient back to the nest. Followers traverse it, but the key mechanism is that they only reinforce the gradient upon a successful return trip with a payload.
I was looking at the differential equations they use for this in the design doc. It's fascinating. because shorter, more efficient physical paths can be traversed more times within a given tick window. The deposit rate on the optimal route vastly outpaces the global evaporation variable,
Yes.
so the network naturally prunes itself. Suboptimal branches simply evaporate because the physical throughput isn't fast enough to keep the chemical state active.
And that pruning isn't just a behavioral trick to make the ants look real. It is a critical optimization for the engine's tick rate.
Oh, because of the pathfinding overhead.
Exactly. Running A-star pathfinding queries for hundreds of independent entities in a dynamic voxel environment, it creates an unsustainable CPU load. It would melt your processor.
Right.
The Colony engine uses those expensive A-star calculations purely for the initial exploratory phase.
Just to find the food the first time.
Yeah. Once a pheromone gradient crosses the specific strength threshold, the engine promotes that physical trail into a permanent waypoint graph edge in the memory.
Oh, that's brilliant. So the engine just hands the navigation off. It stops calculating spatial paths and just lets the entities traverse a rigid, pre-calculated graph.
They transition from dynamic spatial search to cheap graph traversal. It's an incredibly elegant way to offload compute cycles by letting the environment store the navigational data.
Okay, but wait. The environment is public.
Yes, it is.
So what does this all mean for the player? If I build a trail-heavy colony, it's fast and cheap on the CPU and the calories, but am I basically broadcasting my infrastructure to the enemy?
Exactly. You are inherently exposing your logistics to external observation, and that deliberate vulnerability is the core of the whole system. But before we get to the warfare side of that, we should round out the third signaling channel.
Right, tandem running. The escorted channel.
Right. This is a highly secure but incredibly brittle protocol. A scout physically leads a squad to a coordinate, relying on local proximity checks rather than environmental modification.
So they aren't dropping any pheromones at all.
None. There is no chemical deposit left in the world, meaning there is zero data leak for an enemy to read.
Okay.
However, the operational integrity of the entire squad is completely tethered to the scout's survival.
Oh, I see.
If the scout goes down, the followers like the internal belief state to navigate back or proceed. The squad is just stranded.
So you are always balancing computational efficiency against data security. If you heavily weight the broadcast channel, your logistics are lightning fast, your CPU load drops. But you are painting a massive target on your infrastructure.
Right.
And the document leans heavily into this exposure. It frames chemical warfare not as a combat mechanic, but as an information inference problem, intelligence and counterintelligence.
Because pheromone trails exist physically in the world, they are readable by enemies. This transforms a simple pathfinding mechanic into a high-stakes inference problem. The engine achieves this by assigning each colony a multi-component chemical signature.
Like a randomized high-dimensional vector.
Yes. When an external entity, like a rival scout, intersects a pheromone gradient, the signature is obfuscated at first. The engine doesn't just flip a simple Boolean flag for enemy or friend.
Right, you don't just instantly know whose trail it is.
No. To deduce the vector, the rival scout has to physically traverse the gradient and run a process of elimination over time. It analyzing the composite markers. The longer it follows the trail, the more variables in the signature vector it resolves.
Wow. And because deduction requires physical proximity and time, it forces the scout to dwell in hostile territory.
Exactly.
Intelligence has a strict price denominated in physical risk.
And think about what that means for counterintelligence. If the scout resolves the vector, the deduction exists locally in the scout's memory. It does not exist in the rival colony's hive mind until that scout successfully traverses back to its own local blackboard.
Right, going back to the finite information propagation.
Yeah, so if you intercept that scout in transit, the intelligence progress goes to zero.
It creates a massive, quantifiable incentive for counter-scouting operations. You aren't just killing a unit to reduce their physical numbers, you are destroying a decrypted data packet before it uploads.
You're killing the messenger. But assuming the data packet does upload, the attacking colony unlocks something terrifying: the inducible trap.
Chemical mimicry.
Yes. This mirrors the behavior of polyergus slave-making ants in the real world, but applied here as a mechanical exploit. Armed with the deduced chemical vector, the attacking colony can synthesize forged gradients.
So they spoof the pheromones.
They deploy infiltration units deep into the victim's territory to lay a closed, circular loop of forged pheromones intersecting a primary logistics corridor.
The circular mill.
Oh, man.
We've all seen the zoological footage of army ants caught in a death spiral, right?
It's brutal.
They just follow the unit in front of them until they literally die of exhaustion. In the simulation, this isn't a glitch, it's a weaponized exploit of the victim's own graph traversal optimization.
That's the genius of it. The victim's entities hand off their navigation to the forged graph edge and enter an infinite state machine loop. It permanently removes them from the economic labor pool without a single point of physical damage being dealt.
Here's where it gets really interesting to me. It's essentially a biological phishing attack. The enemy spoofs your colony's IP address, but the engine provides a biological countermeasure, right? Path integration.
Yes, modeled on the cataglyphus desert ant. Dead reckoning.
But this countermeasure is not active by default, is it?
No, it requires a heavy caloric and developmental investment to instantiate in the worker caste. You have to pay for it.
So we are talking about vector calculus here. An entity running dead reckoning is continuously maintaining a vector pointing back to its origin, updating its accumulated distance and its net displacement.
Exactly.
If an entity gets caught in a forged circular mill, its accumulated distance traveled will continuously scale up, right?
Yes, because it keeps walking.
But its net displacement relative to the nest remains static. It's not actually going anywhere. So the math trips an internal threshold, the entity recognizes the discrepancy, breaks the loop, and flushes the local graph data.
It acts like multi-factor authentication. They realize the loop is a scam and break out. It's a verification layer against environmental spoofing. If a colony relies purely on the cheap stigmergic trail following to save caloric investment, they remain completely exposed to mimicry.
It's such a perfect system. The mechanics cascade naturally from the foundational constraint. Like finite information necessitates trails, trails leak data allows spoofing, and spoofing requires vector-based path integration to defend against.
It's an arms race driven entirely by the cost of information.
Which brings us to space, frontage, and the net negative economy of war. Because even with all this espionage, eventually information warfare devolves into a kinetic exchange, physical combat.
Right, but the document severely restricts how combat functions. It imposes strict underground geometry and what they call the iron rule of balance.
Let's look at the geometry first. They explicitly cap paired combat at two entities. If multiple units converge on a single coordinate, the engine forbids arbitrary stacking.
Right, because allowing arbitrary combat stacking destroys tactical geography. If 20 ants can occupy the same block and attack at once, the optimal solution simply becomes accumulating a massive, undifferentiated sphere of entities.
Just a death ball.
Exactly, a death ball. By capping the interaction at a bonded pair occupying a single tile, they align the combat logic perfectly with the constraints of a one-block-wide voxel tunnel. Two bonded ants maximize their attacking frontage in that confined space.
It fundamentally links the colony's excavation logistics to its defensive doctrine. This is so cool. If you dig a one-block-wide tunnel, you severely bottleneck your own logistical throughput.
Because workers moving payloads will collide.
Yeah, forcing the engine to run avoidance calculations and slowing down caloric delivery. But you create an absolute defensive choke point.
Conversely, excavating wide multi-block chambers optimizes the flow of traffic but exponentially increases the defensible frontage. It opens the colony up to flanking maneuvers by infiltration units. You are constantly balancing economic velocity against structural vulnerability.
Every block you dig is a strategic choice. And even when a combat engagement concludes, the aftermath is governed by strict biological timing. The engine models the accumulation of oleic acid.
This is one of my favorite details.
When an entity is destroyed, its status doesn't instantly flip to corpse on the environmental layer.
No, there is a latency between death and the chemical signaling of death. This means there is a temporal window where the wreckage simply acts as inert physical blockage before the colony sanitation protocol triggers.
It literally clogs the tunnel.
Yes. Once the oleic acid threshold is reached, the wreckage becomes a task object, pulling active labor away from caloric foraging to perform sanitation hauling.
And the economics of hauling that wreckage introduces the iron rule of balance. The document insists that kinetic warfare must be net negative calorically. The nutritional yield harvested from an entity's corpse must mathematically be lower than the caloric expenditure required to birth, maintain, and risk the defending unit.
This is critical, because if the equation ever flips positive, if harvesting a corpse yields a caloric profit, perpetual warfare becomes the optimal strategy. The simulation just degenerates into a constant meat grinder, completely abandoning the logistical, excavation, and informational mechanics.
Yeah, it just becomes a pure combat game.
Right. By enforcing a net negative return on combat, The engine forces the player or the algorithm to treat warfare strictly as a spatial control mechanism.
So if war is always an economic loss, why would a colony ever fight?
To protect foraging routes, you don't fight for resources directly. You fight to secure the physical geometry required to protect your foraging graphs. The entire game loop relies on the fact that food dictates the population cap, which dictates the guard count, which dictates the defensible territory.
You fight for space, not for profit.
Yeah.
Every engagement is a calculated burn of your own economic runway to secure future logistical capacity. But wait, modeling all of this, the vector-based dead reckoning, the oleic acid delays, the A-star graph pruning, this requires an immense amount of processing power. To prevent catastrophic CPU bottlenecking, the developers had to architect the system in two distinct layers, right? The oracle and the virtualization wall.
Right. To simulate these intricate rules without crashing the computer, they built what they call a standalone deterministic kernel, the oracle.
So it's a headless simulator. It doesn't even run inside the visual Minecraft client initially.
No, it operates on its own abstract voxel grid with a rigid, fixed-step tick loop, and the determinism is absolute.
Meaning what exactly?
Meaning, if you input a specific seed and a precise log of events, it must execute bit-for-bit identical outputs over millions of ticks.
Wow. Why is that so important?
Determinism is mandatory for analyzing complex multi-agent systems. When you are relying on emergent phenomena, like a circular mill spontaneously forming out of the math of pheromone gradients, you cannot tolerate floating-point non-determinism.
Because if a bug happens, you need to know why.
Exactly. In a standard engine, if a synchronization bug occurs between two agents, it might just vanish on the next run. You can never track it down. In the Oracle, a bug is a permanent artifact. You can inject the seed into a debugger and watch the collision occur identically, frame by frame.
So it provides a flawless control environment. You can isolate a single variable in the chemical deduction vector, run the simulation, and diff the outcome against the control with absolute mathematical certainty.
Yes, it's full fidelity. But the Oracle is a development environment. Eventually, they have to integrate this into the actual voxel client for real-time interaction, and that means running face-first into the performance wall.
The document references past mods that attempted biological swarms, like ant arsonist, and they failed catastrophically around 20 or 30 entities.
Yeah, they had to resort to hard-coding a proximity louche to keep entities near a central chunk to avoid memory overflow.
So to support 60-plus ants, the Colony engine bypasses this by utilizing aggressive level of detail, LOD virtualization.
Right. When entities cross outside the player's render distance or outside a specific chunk update radius, they are stripped of their physical instantiation. The engine simply ceases to calculate their spatial coordinates, their collision meshes, or their local pathfinding.
They degrade into abstract statistical state machines.
Exactly.
So instead of tracking every single commuter as car on the highway, the game just looks at a spreadsheet that says traffic is heavy today, 5% of cars will get flat tires, and it only renders the cars when I look out my window.
That is a perfect analogy. The entity becomes a matrix of probabilities. A foraging unit on a known graph edge is reduced to a background calculation that returns a specific caloric yield per 1,000 ticks, modulated by a known mortality probability derived from the overall threat level of that chunk.
But the difficulty with statistical LOD in simulation design is drift, right? How do you guarantee that your abstract probability matrix accurately represents what the physical entity would have accomplished if the physics engine were actively rendering it?
You diff it against the oracle.
Of course.
Precisely. You run the full fidelity physics-enabled simulation in the headless kernel. Then you run the virtualized LOD version using the identical seed. You extract the trajectories and the economic outputs and compare them.
And if they don't match?
If the abstract statistical yield diverges from the deterministic physical yield by more than an acceptable fractional tolerance, your probability matrix is flawed. You adjust the statistical weights until the virtualized abstraction perfectly shadows the physical reality.
So you can trust the spreadsheet because you've proved it against the physical math. The Oracle isn't just prototyping scaffolding. It is the permanent calibration harness for the virtualization layer.
It's incredibly rigorous software engineering.
Which brings us to the core revelation of the entire document, the true purpose of all of this. Why go to such extreme length to ensure perfect deterministic modeling of ant communication and economics inside a video game?
Because they aren't building a game, they are building a laboratory.
Right. The Colony engine is heavily integrated with external research on self-repairing legged robots. We are talking about physical hardware designed for environments with zero human oversight, like deep-sea exploration or extraterrestrial deployment.
And this is where it all clicks together. The associated white paper details a robotic swarm framework utilizing NEAT, neuroevolution of augmenting topologies.
Okay, what does that actually mean for the robot?
When a physical unit suffers structural damage, like, say, a sheared servo on a locomotive limb, it doesn't just execute a pre-programmed limp, it possesses an internal mechanical avatar. It runs thousands of rapid evolutionary generations to construct a novel, asymmetric walking gait based on its new physical topology.
And it tests that new topology using an ant dance, right?
Yeah.
A series of physical micro-movements to verify if real-world friction and torque match the internal neuroevolutionary model.
Exactly.
But wait, you can't test those physical joint torques in a voxel engine. Minecraft lacks the granular physics for that. It doesn't have center of mass dynamics or variable friction coefficients. It's just blocks.
Minecraft is entirely useless for testing robotic gaits. Attempting to validate a physical locomotive gait inside a voxel engine would merely validate your own abstract physics approximations. It yields zero actionable data for the physical hardware.
So what are they testing?
The researchers are fully aware of this limitation. The Colony engine is designed to test the operational layer above the individual unit's locomotion. It tests the Beowulf swarm layer.
The Beowulf swarm layer. Let's break that down because this is where the engine's insistence on finite information propagation becomes absolutely critical. If a robot sustains damage, its local compute might be insufficient to run the necessary NEAT generations before it suffers catastrophic failure or battery depletion.
Right. It needs to offload the neuroevolutionary processing to the swarm, distributing the compute load across healthy peers.
But in the Colony engine, governed by physical couriers and relay latency, requesting compute power requires transmitting a data packet across hostile or degraded terrain. The relevant constraint isn't processor speed, it is communication topology.
Yes. How many functional peers can the damaged unit physically reach before it fails? The latency is the actual physical transit time of the courier.
Right.
If the courier takes 300 ticks to navigate the voxel geometry to reach a healthy node, and the damaged unit is burning baseline power just remaining online, the latency itself might be a fatal constraint.
And the healthy peers donating their compute cycles are temporarily paralyzed, right?
Exactly. They aren't foraging, they aren't defending. Saving a damaged unit incurs a massive, quantifiable economic penalty on the macro structure of the swarm.
This blows my mind. They are using a voxel video game not to figure out how a robot walks, but to figure out if the robot society can afford to save it when it falls down.
That is exactly what they're doing. The engine allows researchers to mathematically model the survival rate of a decentralized network under severe physical attrition, and the voxel environment provides an incredibly cheap, highly varied testing ground for diagnostic algorithms. Specifically, the document highlights Section 7.1 discrimination tests.
Section 7.1. This addresses the core vulnerability in self-modeling robotics, right? Misattributing external environmental friction as internal structural failure.
Yeah.
So if a robot traverses a yielding surface, like deep sand, its locomotive efficiency plummets. If its internal diagnostic AI incorrectly attributes that drag to a sheared gear, it will overwrite a perfectly functional control schema to compensate for a non-existent injury.
Right. It effectively cripples its own software to adapt to a hardware fault it doesn't even have.
So the unit must be capable of discriminating between an internal topological fault, which remains constant across various maneuvers, and an environmental disturbance, which fluctuates based on external variables.
And this is where Minecraft shines. The voxel engine offers a massive library of distinct environmental modifiers for free. Soil sand, packed ice, honey blocks, web structures.
You instantiate the robot not with physical joints, but with an abstract capability matrix. You degrade the matrix internally to simulate a hardware fault, and you degrade it environmentally by forcing traversal over soil sand.
Yes, and because of the headless oracle, you can run identical environmental disturbances on identical initial states across tens of thousands of diagnostic policy iterations. You are tuning the algorithm's ability to accurately isolate the source of the drag under heavy sensor noise.
It allows the researchers to refine the diagnostic isolation protocols without risking physical hardware. But the most profound output of the Colony engine is the macroeconomic threshold it forces the researchers to calculate: triage versus repair.
This is the ultimate question. In a single unit paradigm, failure to repair means total mission loss. You have to save the rover,
Right.
but within a massive stigmergic swarm, the researchers are forced to balance the localized cost of repair against the systemic cost of replacement.
There's a mathematical crossover point where the compute cycles, the relay latency, and the physical vulnerability incurred by attempting to salvage a crippled node far exceed the caloric and temporal cost of simply gestating a replacement.
Yes, we are looking at an incredibly complex multivariate equation. Larval gestation lead times, current caloric surplus, physical distance to the damaged node, the probability of courier interception. The colony engine dynamically calculates when the optimal policy is to just abandon the unit entirely.
That is so dark but so efficient. And that macroeconomic insight directly informs the microengineering of the physical robot. It dictates exactly how much redundant processing power and physical recovery hardware you bother installing on the individual frame.
Right. If the swarm economy dictates abandonment 80% of the time, engineering robust, heavy, expensive self-repair hardware into every single unit is a massive waste of resources.
The design of an extraterrestrial or deep-sea robotic swarm is fundamentally shaped by the economic constraints mapped out inside a voxel simulation of ant stigmergy. It's incredible. The architecture strips away omniscience, forces finite physical routing, subjects that routing to espionage and voxel geography, and uses the resulting latency to define the very limits of distributed computation.
And it all loops back to that core concept of stigmergy. We are observing complex, highly structured systems emerging entirely from local agents reading environmental modifications left by unseen peers.
Which is brilliant for robots.
It is, but it leaves us with a fascinating and somewhat unsettling structural parallel.
Unsettling how?
Well, we engineer these highly constrained stigmergic environments to study artificial swarms, but it demands an examination of our own macro structures. Consider the architecture of global supply chains or algorithmic market trading or decentralized data networks. We assume there is a macro awareness governing these systems, some sort of rational God view.
But there isn't.
No. Fundamentally, human, economic, and digital structures operate on massive layered stigmergy. Millions of independent agents modifying localized environmental data, prices, API calls, digital routing tables.
We're all just acting entirely on the pheromone gradients left by others, utterly blind to the global skate machine.
Exactly. We are building the anthill through localized environmental reactions, and the colony engine demonstrates how easily a stigmergic network can be exploited if you deduce the compositional signature of the gradient. If a localized swarm AI can optimize a circular mill by spoofing environmental data to trap ants, it is worth considering what the equivalent of a weaponized inducible trap looks like when deployed against human stigmergic architecture.
A biological phishing attack on human markets.
Right. When the entire system is just agents reacting to trails, injecting forged data into the environment doesn't just disrupt a single node. It rewrites the physical behavior of the entire macrostructure. What happens when someone learns to forge our signals?
A sobering thought for anyone modeling large-scale network behavior. We will leave it there for today. What an incredible journey from a Minecraft mod to the cutting edge of robotic swarm logic. Thanks for joining me on this deep dive.